Hello everyone, in this video I'm going to be solving for the integral of x to the power of 3 times square root of 9 minus x squared dx. But in this case, there are two ways to solve for this integral. But I'm going to be showing you guys how to do the easier one and the faster one first. We're going to use a U Substitution Rule and set u is equal to 9 minus x squared, which would give us the du as negative 2 times x dx. If we divide negative 2 on both sides, then we would have negative 1/2 times du is equal to x times dx. The negative 1/2 can go in the front since it's a constant, and we can actually change the x cubed with x times x squared, so that when we are replacing the x times dx with negative 1/2 times du, it would be easier, and we can just cancel this dx and just this x. If we do that, we would just have x squared times the square root of u left, and also the du. We have to replace the x squared with something that is in terms of u. So we're going to we're going to use this equation here to replace the x squared. X squared would be equal to 9 minus u. And if we replace x squared with 9 minus u, then we would have negative 1/2 times the integral of 9 minus u times the square root of u. Multiply these two together to simplify it more, and so that we can take the integral of this easier. Now that we have multiplied these together, we can take the integral now. The integral of 9 times square root of u is equal to 9 times 2 over 3 times u to the power of 3 over 2, and minus 2 over 5 times u to the power of 5 over 2, and plus the constant. We can simplify things a little bit more. Now we can substitute the u back, which is equal to 9 minus x squared. This would be our answer for the integral of x cubed times square root of 9 minus x squared dx. Now I'm going to teach you guys how to solve for this integral the other way. Now for the other way to solve for this integral, we're going to use trigonometric substitution. If we set x is equal to 3 times sine theta, then that would give us the dx as 3 times cosine theta d theta. We're going to put in 3 times sine theta into the x here and here, and we have to cube it, so if we do that, then we would have 27 times sine cube theta times the square root of 9 minus 9 sine squared theta times the dx, which is equal to 3 times cosine theta d theta. This is a trigonometric identity, and 9 minus 9 times sine squared theta is equal to 9 times cosine squared theta, but since we have the square root, we would just have 3 times cosine theta. And we would have 27 times 3 times 3, which is equal to 243, and times 243 by the integral of sine cubed theta times cosine theta, which is equal to cosine squared theta. And we're going to change the sine cubed theta so that we would have sine theta times sine squared theta. And sine squared theta is equal to 1 minus cosine squared theta. We're going to substitute it like that, and we would get 243 times the integral of sine theta times 1 minus cosine squared theta times cosine squared theta d theta. We're going to use U substitution rule for this part, and if we set U is equal to cosine theta, that would give us a du as negative sine theta d theta. We can multiply negative 1 on both sides, and you will have negative du is equal to sine theta times d theta. We can replace the d theta and the sine theta with negative 1. So I'll move on to here. I'm going to work here now. So we have the negative 243 times the integral of 1, it's 1 minus u squared times u squared, since cosine theta is equal to u, and du. If we multiply these two together, then we would have, I'll move up to this part now, up here, and negative 243 times the integral of, if we multiply these together, then we would have u squared minus u to the power 4 times du. Now we can take the integral now. If we take the integral, then we would have negative 243 times 1 over 3 times u to the power of 3 minus 1 over 5 times u to the power of 5 plus c. Okay, now we can substitute the u back here, which is equal to cosine theta. So this is equal to negative 200 that. Wait, hold on. Let me simplify it a little bit more by multiplying these two together. If we do that, then we would get negative 81 times u to the power of 3 plus 243 divided by 5 times u to the power of 5 plus c. Now we can substitute the u back in. I'm going to erase this part again now. If we substitute the cosine of theta into the u again, then we would have negative 81 times cosine cubed theta plus 243 divided by 5 times cosine to the power of 5 theta plus c. But we have to change our answer so that we would have it in terms of x. And the way we're going to do that is, so the way we're going to change this in terms so that we would have it in terms of x is by using this. X is equal to 3 times sine theta. I'm going to erase this part so that we would have more room to write on. And if we have x is equal to 3 times sine theta, I'm going to focus on changing the cosine cubed theta so that we would have it in terms of x first. And using x is equal to 3 times sine theta, we can create a right triangle with it. If this angle is equal to theta, then, well, here, sine theta is equal to x divided by 3, but sine theta is equal to the opposite over the hypotenuse in this right triangle. So that means that the opposite is equal to x, the length, and the hypotenuse is 3. Using Pythagorean theorem, we can find that this adjacent length is equal to square root of 9 minus x squared. And cosine theta is equal to the adjacent over the hypotenuse. The adjacent is equal to square root of 9 minus x squared, and the hypotenuse is 3. So we can replace the cosine theta with this, but since we have it cubed, we would have to have, well, negative 81 times cosine cubed theta, which is equal to this cubed, and plus 243 divided by 5 times cosine to the power 5, which would be this to the power 5. And now I think I found our final answer for the integral of x cubed times square root of 9 minus x squared dx. Thank you so much for watching this video, everyone, and I hope you guys learned something from this video. Bye!